Okay.
Thanks.
Okay. So we drafted a plan for ambient mesh beta telemetry. And please take a look. And if you have comments, please add to the doc. That's all.
So Lei, I was just looking over the doc, and I noticed that the top item there is that you're moving for sort of the waypoint single-sided or single telemetry, which includes both the client and server pod identity and very high cardinality. It seemed like when we talked about that 2 weeks ago, we were leaning away from that option. Can you describe what has changed since then?
I think in our last discussion about waypoint single versus waypoint double, the waypoint single is the preferred approach. The reason being that even though the waypoint single has higher cardinality, but it can provide the source to destination information. The waypoint double, however, right, that information is not there. So you can't know, which is the source, which is the destination.
Lei, I wonder, would it be worth, because we don't have a lot of other agenda items, would it be worth just maybe presenting the doc and quickly going over it? And then it might be good to refresh some people's memories what we're talking about with the single versus double in case anyone wasn't here.
Yeah, to be honest, I haven't prepared for it, but I can, open, I think John is here. John presented, is John here? I think John presented the waypoint single versus double approach. Oh, John is here, yeah.
Well, I was thinking also the proposal is pretty straightforward. I mean, just so that people might be just worth quickly just going over what the high level suggestions.
Okay, yeah. Let me maybe give a outline of the proposal. Yeah. Someone raise the hand or okay. 1 second. Okay. So we have reached a few consensus. One is, the consensus over the waypoint single approaches versus the waypoint double approach. And another part we reach a consensus in previous work group meeting is the waypoint proxy will provide the existing OSS EC2 metrics for backward compatibility. And Zeton will provide the OSS EC2 TCP metrics. And we also discussed whether we will provide the OTLP-based telemetry. And the consensus is it's not required for OS Ambient MVP and can be added later. And we also agree that hotel semantic convention for OSS Ambient is a good idea, and we may add that in the future. So that's some existing consensus. And next part is some plan for the ambient mesh beta. So I will not read it line by line. But maybe I can outline the key ideas. So for metric, right? So the user experience will be similar to the OSSE still. Promises can script the metrics, and the logs will be outputted to std out, and the waypoint logs will be like the Envoy access log, just like the OSSE still. And the Z-tunnel will provide the TCP access logs, but it's not in the Envoy log format, because the Envoy log format is designed for HTTP. And the Z-tunnel is a Rust program. It has its own TCP access logs. And it will be outputted in JSON format for easier log consumption. And let me take, okay, for tracing. Tracing will not be supported for Z-tunnel because Z-tunnel is L4. It has TCP packets, and tracing header, in order to support the tracing header needed to be added to the HTTP headers. And the Z-tunnel doesn't modify packets to add the tracing headers. Yeah. Oh, John, okay. John saying, let me read John's comment. We can actually trace at the connection level if we want it. Okay.
So John, would that be a bunch of disconnected trace spans? Or,
yeah, you want
to
be able to connect the user's trace, but you could see from both the two Z-tunnels. I don't know that we actually should do this, but today we actually do this to some extent by sticking a header, and then you can correlate the logs on the source and destination Z-tunnel, for example. Just pretty like whether we want to actually be able to emit that to a tracing provider and do all that, it's probably a bit overkill, but.
And Benjamin saying packet trace. So Benjamin, for packet trace, which header it is using?
I'm saying, yeah, like connection level, packet level, that's something we could do, but I agree with John that I think that that's probably more than we need right now. That's not what people actually want. Yeah, they want request level.
Okay, cool. Okay, so for waypoint policy, the tracing can be same as that of Istio gateway, and the implementation can be same as the OSS Istio. The next part is about the telemetry API, and for the waypoint, the telemetry API can be used to configure metrics, enable, disable access logs and the tracing. Just like the telemetry API can be used to configure the telemetry for OSS Istio. And for Z-tunnel, the metrics and the logs can be always enabled without configuration through the telemetry API. And that actually simplifies implementation and configuration. But if there are user requests to support the telemetry API for Z-tunnel, we can discuss such requests. Next section is about the work to do, right? So for Z-tunnel metrics, there's a bunch of existing works. For example, current Z-tunnel implementation implemented OSS Istio TCP metrics. And these metrics have already been implemented in the way that it can be support Prometheus script. And also the metric labels have been implemented. And the work to do mainly is to add the tests. So for example, adding the test to verify the Z-tunnel metric value and the labels are working as expected. And the user guides also. So for waypoint metrics, So the work to do includes implement the waypoint metrics in the waypoint single approach, and also the tests to verify the waypoint metrics.
I was just gonna, I thought this might be a good time to mention the question that Mitch brought up, because I also remember that discussion with the waypoint single versus the double. And so just as a quick rehash, the question is whether the waypoint would want to terminate the telemetry for both ends of the connection. So we basically, if traffic is going from 2 Z tunnels and it's transiting a waypoint, do we keep track of the telemetry separately for each end? And I think that the reason that the double approach would reduce the amount of logging that would be necessary, but it's a little bit less useful because you don't see the end-to-end traffic that when traffic is going from one Z tunnel to the other Z tunnel.
I can give a quick and intuitive answer to this question, right? So the waypoint double approach is like there is a mixer in the middle, right, between 2 Z tunnel, and this mixer essentially only knows 2 sides, but it doesn't know the source to destination pairs. Essentially, the reason it reduces the cardinality is it doesn't maintain these combinations between source to destination. Instead, it knows, okay, which sources send to me and which destinations I'm going to forward to. But it doesn't, the cardinality coming from this, X times Y, X being the source, Y being the destination. Yeah, costing, yeah.
Well, it does know both the source and destination, because obviously we have, Z tunnel has enough information about the source and certificate and all that. No, the reason I believe that we decided that we want only one side is that, again, it's not that it's double, it's that there is a purpose behind it. The purpose of client side is to capture the latency, the network latency between the client and the server, which can be, you may cross regions if you have poor load balancing and you need to adjust, and to capture errors that happen on the network path. And the server side metrics were intended to give you information about the health of the service itself. I mean, what is the latency of the service? If it increases, get alerts and all that. In a waypoint, if they're in the same point, you don't capture the first. If we had 2 waypoints, I mean, an egress waypoint in close to the cluster and in the same zone with the client and destination waypoints, then yes, it will be reasonable to have two sides of telemetry. But, and open telemetry semantic conventions also kind of make very clear distinction between the new semantic convention for HTTP with the client telemetry having a certain set of labels and server telemetry having a different set of labels and different names, actually. So it's no longer even the same name, it's a different metric.
So Benjamin commented there is no way to compare 2 data sets. Essentially, my understanding of Benjamin's comments is there is no way to correlate the source to destination because you maintain 2 separate set of data sets.
But it's clear that, I mean, it's a HTTP request. Now you have request headers, request the identity, with the client because you authenticate it, and you forward.
Particularly, it seems like if the waypoint represents a single service, then you have everything you need in one-sided, right? Because all traffic from any client to the waypoint represents client to the destination service. Where the complexity arises is when you have waypoints representing multiple services.
But you have a host header, so you know exactly what service it is. It's virtual. I mean, it's like abstractions. Yes, it's a single process, but you have all the information in the data.
So I think Kuat raised a great question in the GitHub issue. If we used the telemetry API to provide some cluster limitations on cardinality. Would it be possible to drive down the cardinality to near the same level as single-sided telemetry, even though we're producing double-sided telemetry from the waypoint? In other words, can we make this user configurable so that they can control their own cardinality?
Isn't it orthogonal?
Each, I'm not sure how this can be user configurable. Let's say if there are 3 potential source and 3 potential destination, and if we really want to know the source to destination relationship, the potential cardinality will be 9. But if we only maintain one, 2 separate set of source destination information, the cardinality will be 6, 3 plus 6. So
Wow.
Sorry, Costin. Yeah.
So to clarify, I mean, cardinality is not only about 3 sources and 3 destination. It's we may track the actual pod identity and as a client and as a server, or we may refer only to canonical service, or so it's the high cardinality is mostly on the pod related identification. Maybe it's just client identity at a service account and service identity as a service account or a service name, canonical service is much lower cardinality than the individual pod labels, pod info.
Well, I don't think we're doing pod to pod cardinality, right?
I believe we do have some sort. I think one of the labels is related to the pod, if I remember correctly.
So for example, we have source workload name, right? And destination workload name. And if they are the same name, then their cardinality is the same, but they may not necessarily to be the same source workload name.
I mean, Prometheus definitely adds the actual pod and a lot of information on the client. I'll double check.
I guess my overall question is not so much if we can completely duplicate the functionality using telemetry API, but rather by putting a few sane limitations on cardinality cluster-wide using telemetry API, can we achieve nearly the same cost for the user? So that we essentially give them the option to operate in a low-cost telemetry mode, and then if needed, if they want the high cardinality, they can expand that.
So Mitch, the part I'm not clear is the detailed mechanism to achieve that, right? For example, we say we want to operate in a low cardinality mode. How do we achieve that? Because that depends on the user's deployments. Can you maybe elaborate on maybe some high-level idea to achieve that?
So cardinality is a product of more than just client and server identity, right? There's I don't know how many dimensions that we actually have on the data. I think in the neighborhood of dozens. And there's certain limitations that are very easy to put out. Like for instance, response code classification. Don't include 503s versus 502s, abstract those out to 500s. That's a very common thing for Istio users to do, and it substantially reduces cardinality where you have a lot of, you do lose the nuance of some of the response codes, but you get their overall class. Are there steps like that, similar to that, that we can take to reduce cardinality using the telemetry API to achieve a similar cost basis to the single-sided telemetry, while still having value in the telemetry without reducing it to meaninglessness? I don't think it's a question that we can probably answer in this meeting. I'm thinking more in terms of going back to that table that John had, where he ran scenarios and reported cost, and seeing how much reduction of cardinality can we achieve in telemetry API with the two-sided mode, and is that enough to give users the control that they're hoping for?
Luis.
So I think there are 2 orthogonal topics here, right? There's what's necessary to ship ambient data. And then what is more control over telemetry look like?
That's fair. And I don't think the waypoint telemetry conversation is necessary for beta at all, right? Because we're launching L4.
Well, we still have to know what we're going to launch beta L7, right? So we still have to make a decision about that, regardless of the timeline.
Sure.
So the point still sounds about these being separate. Right? As far as I remember, the biggest single multiplier of cost, right, is latency histogram. And we're waiting for Prometheus to fix that. As John points out, right, you can use Prometheus Federation to do cardinality collapse, right? As part of the infrastructural toolchain on the backend side, without trying to push that complexity or trying to handle that case in the data plane. So we have to focus on these two questions, these questions independently. What are we going to ship for beta at L7? And then how are we going to do something better? Right, and I believe the outcome of the conversation 2 weeks ago was in the short, right, the unblocking decision is ship what we currently have, or as close as an equivalent to what we have at SideQuest today, and commit to that for beta, and then start working on something better and design that independently of those the other thing. And figure out how to give users actions.
What we have really is gateway. I mean, waypoints are gateway, not sidecars. So, and I completely agree. We ship what we have. I mean, the gateways and waypoints are more or less interchangeable. The telemetry generated by gateways is the most relevant for waypoints and, the most accurate.
Well, I wouldn't. Right, that's not the user expectation of what we have. To use your parlance, that's it. Right? Yes, we have gateways. But users are used to telemetry east-west, right? That has a single reporter showing both sides. That's what we've made users accustomed to. That's certainly what we made Kiali accustomed to.
True,
if we want to change that, right? Then we have to have a design for changing that.
But Louis, I mean, we use people to have client-side telemetry, which has extra information about network latency, but that's not possible in the new design. I mean, even if we generate two sets of telemetry.
There are laws of physics limitations. We can't do everything that we used to do. I agree with that completely. So the question is, how do we do as much of what we used to be as compatible as possible?
Having two sets of data with exactly the same number and the number not actually being what the user expects, including network latency, is not really useful for anyone. It's just confusing.
I'm not sure what you mean by two sets of data.
So having dual set of telemetry generated by client-side generated by waypoint, isn't that what we are discussing?
No, we're saying either the waypoint reports the unified set of dimensions for the single fact, or waypoint partitions the dimensions into a client and producer side set and duplicates the fact.
Yeah, so the first is what I think is the right option. The second one I think is misleading because if it separates two dimensions, it would give the false impression that they're client and server, and again the difference between them would be that you use client for different purpose. It's the same value.
So, like when I say like we report one set of dimensions, that would include the client dimension and the server dimensions when reporting a single fact.
Yeah, client dimensions, yes, but it's not client value. I mean, the latency is not the client latency. So if we report latency, the latency, whatever dimension we report.
Yes, we are not reporting client latency. We're just reporting who the client was with precision.
Yeah.
So I think Costin is talking about the reporter field, client or server side reporting. As far as I understand it, we're not planning on having both of those values in the waypoint. Louis is talking about the identity of the client and the identity of the server or service, which will continue to be dimensions of the data.
Oh, I agree with that, of course.
Okay, so I think that's what Lei's document says, which is the single view. Obviously, the terminology is a little complicated.
Yes.
But there's one report of the waypoint. It reports two sets of dimensions for a single fact. the client's the client dimensions and the producer dimension, server dimensions are unified, and one fact is reported. And that's like if the fact is latency, it's the waypoint perceived latency of the server. We don't claim that it's the client's perceived latency, right?
Okay, can we move to the ztunnel logs? Okay, so ztunnel currently have, like I mentioned before, right? It's a Rust program. It has existing logs, and it will be outputted in JSON format. And we needed to add a test to verify the ztunnel logs are working as expected, user guides to document the supported ztunnel access logs, and waypoint logs. It will be reusing the existing Istio Envoy access log implementation. And the logs will be output to std out in JSON format. And we need to add tests and user guides. And the waypoint tracing, it will be reusing the existing Istio tracing implementation. And we need to add tests and user guides. So for telemetry API, so the telemetry API will be available for config the waypoint telemetry, but not ztunnel. And this will be reusing the existing Istio telemetry API implementation. And we need to add the tests and the user guides. Yeah, that's all.
John, I know in GitHub you had mentioned some concern about ztunnel log format. Is this the Envoy TCP format, the format you were hoping to see, or was there something else?
No, the Envoy TCP format I think is a terrible fit because it's really shoving one. It's just not good even for HTTP, but it has all this. Most of the fields are HTTP, so we just have like dash 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 dash, then some useful information. And we don't actually have all the information we want either. So it would make a lot more sense to just have, here's the source info, here's the dest info, and maybe some bytes sent or received or whatever, and connection duration. So.
Yeah, I suggest that we go and look at some of the VPC flow log standards for inspiration, rather than looking at Envoy. And Envoy does not a great job. It's trying to look like HTTP access logs from Apache based in code that was written in the 90s. Things have moved on. Yeah, so I suggest we update the doc on that front.
So Luis, I
only...
lost. Yeah, sorry.
Go ahead.
Yeah. I only heard the first part of you mention adding some logs. There is a reference. Can you send the link?
I'm suggesting we look at VPC flow logs.
Okay, VPC flow logs.
IP flow logs is a better basis for a standard output format than Envoy TCP log, which is trying to fit into the HTTP access log format. It just doesn't make a lot of sense.
Okay, I will add to the doc that the reference the VPC flow logs.
Justin, you have a lot of background here. Is there an industry standard or a kind of at least an implied?
I think there was things like SFlow. Let me see. It's been a while since I looked at this stuff. That was more for like L3 analytics. But it's been a while since I looked at it. But yeah, I can add it. But this was like kind of often a standard in L3 networks.
The other thing, like SFlow would be sampling, right?
Yeah, you're right.
Or that's the other thing, right? Like for high throughput TCP connections, if we're producing log lines for each connection open close, right? It could be log. We don't necessarily want log all the time, right? So we have to think about rotation, sampling, and ephemerality. I mean, waypoints produce staggering amounts of logs, so this might not be super relevant, but we do have to think about it.
Sanjeev, you added a question, metrics indexed by source destination identities or identity plus protocol type plus port. So metrics has labels. Port is not part of the metric label, and source workload name in current Istio metric we have source workload name, source workload namespace, destination workload name, destination workload namespace, and also source canonical service name, etc. But it doesn't have. I don't think it has a protocol type label. And the question, another question is, are metrics merged for all TCP ports sharing the same identity? I think the answer is yes, because it doesn't use the port as a label, a dimension to separate different. Essentially metrics are time series. It doesn't have a port to distinguish different time series. So if the source and the destination is the same, then it's for the same time series.
So if there are two applications running on two different TCP ports in the same pod connecting to a remote server, their connection metrics would be merged, even though there are two applications in the same pod.
So the application, do they use the same source and destination, identity information? If so, then they are reported as the same.
Yeah, I mean, it seems like maybe this is a side topic, but at some point it might have been useful to have metrics for the case of multiple apps running on different ports in the same pod, different ports on the same pod, because they're basically two different clients talking to a server.
Yeah,
but the same identity though.
Yeah, but like Mitch mentioned, right, we want to actually reduce the cardinality. So sure, we can add more dimensions, but it has pros and cons. Because I think previously one issue is for some deployments, right? For example, there are 100 source, 100 destinations, and they suffer from cardinality explosion issue, and they, after running for a while, then they crash, right? The memory overhead, right? So I'm a little bit hesitant to say yes to adding more, labels or dimensions to metric, but
We should be able to add off by default labels, right?
Yeah, exactly.
So a port label that is available, but by default is suppressed using the telemetry API, and customers can turn it on as needed. But Sanjeev, I'm a little bit interested in that use case. So when the client makes an outbound connection, you've got multiple applications, probably multiple containers running within the pod, and the outbound port is static. It's not provisioning an ephemeral port for that outbound connection.
No, it could be an ephemeral port, but again, these are two apps running on two different ports of the same pod. Regardless
So
of whether
if it's
static.
ephemeral, then you have a cardinality explosion, and you really don't necessarily know which ephemeral port belongs to which application, right?
Yeah, so I'm not saying that. So like you said earlier, firstly, to address the cardinality explosion, you turn it off by default, or you have configurable metric, configurable cardinality and all of that kind of thing. But in conventional sort of net flow kinds of metrics, there are various dimensions which are turned off, but customer can selectively turn off fine-grained metrics if they want to examine, I want to know why the two flows from this particular pod are behaving differently. So you can you don't have to turn it on by default for sure. As far as the ephemeral versus static port, I'm not sure how that changes anything unless I'm missing something. But you can eventually, uh, regardless of whether you want to do it by mapping to port. But the point here is that if there are two apps running in the same pod, at the moment we don't have a way of distinguishing them. And do we want to consider having an optional uh, filter to distinguish between two apps running on the same pod? Whether we track
Right.
that.
I guess my question is, if the ports are ephemeral, you still don't seem to have a way to distinguish between those two apps, right? You have port 60,127 and port 59,283. Which port is which app?
Yeah, you would need to map to figure out which port mapping has currently being which is this ephemeral port, which container, for example, is this ephemeral port currently being natted to.
Okay, so the actual dimension on the data wouldn't necessarily be port, it would be container name.
Yeah, basically it's application level metrics, whether that application
see.
is identified by its port or something. But basically there are two apps running in the same pod. Do we want to have an option which is turned off by default, but sometimes can allow you to distinguish them?
Okay, that makes sense. Thank you.
Sanjay, usually when you have logically two applications running in the same pod, they're presenting different APIs, right? And they're partitioned by the grouping of API operations.
I didn't. Sorry, can you repeat, please?
When you say two applications running in the same pod, right? Like, as far as Kubernetes is concerned, two containers in the same pod are the same application.
Well, two processes.
Right, yes, they're processes.
Yeah,
but usually what ends up happening in reality is those processes, like, they have different APIs.
Yeah,
Right,
but let's say
API
these are
services.
two client processes, right? These are two client processes accessing potentially even the same remote HTTP server. Or I don't know, it's a bit of a speculation here, but I just wanted to note.
Yeah, so I think ztunnel could probably report in its log, which is effectively a flow log, with some information about, more information about the origin in a log. I don't think we could do it in telemetry. Waypoint wouldn't go.
I mean, that's fine. We can decide that, hey, our design at this point is we collapse all the metrics. We treat a pod as a single entity, and if there are two processes within the pod which are initiating connections, we merge their metrics. And if we want to add cardinality in the future, we could. I just wanted to just confirm that we don't currently have any way of distinguishing between two processes running in the same pod.
We do. ztunnel probably could, right? Because it's running on the node and it has privilege, so it probably could do that. It could map ephemeral port back to process ID. I'm not sure it makes sense to do it, but it could. Waypoints definitely can't. Right, so it would be restricted to TCP.
Yeah, so we could just document that at the moment we don't do that, but if somebody comes up with a need for it, then it could be done in the future. So it was a bit of a diversion, but I just wanted to, because we were talking about cardinality and client identities, we're essentially treating the entire port as one entity. Oh, entire pod as one entity.
Right, back to you.
Leigh, I have just one question about towards the end of this document, and it may just be that I'm not well informed. Under telemetry API, it says that we need the telemetry for the waypoint telemetry. Does telemetry API not apply to ztunnel telemetry as well?
Yeah, so the in my opinion, right? So the Z tunnel, right? Z tunnel is a Rust program. Currently, it has the metrics, it has logs. They can be always enabled. It's always there. There is no configuration needed or no customization needed. It simplifies the implementation and the configuration. That's my thoughts. Yeah.
So like, for instance, the telemetry API provides a way to select a telemetry provider. Would that not be relevant to the Z tunnel as it is to the waypoint?
Yeah, so Z tunnel, for example, for logs, it can always export it to std out, right? Then you can do whatever redirection, for example, redirect to your backend, log backend, but it's up to you, right? For OSS implementation, it will be just simpler. And for metrics, right? Similarly, it currently support promises scraping, right? You can scrape by promises. You can deploy your hotel collector to, exporting to essentially fetch the metrics and then export to your own backend. But the key idea is less customization, less configurability, less implementation, less burden, and that's for Z tunnel. For waypoint, it's similar to ESQ, right? You can configure a bunch of things, right? For example, enable tracing, disable tracing, enable certain access log, disable certain access log.
I guess for my part, I would be a little bit surprised as a user if I configured, say, a Datadog provider for pushing telemetry, and that only impacted my waypoints, and I didn't get layer 4 telemetry there.
So let me think about what you're saying. So you are saying that you want layer 4 and layer 7, right? But for layer 4, it's still there, right? It's std out. You can do your own. I mean, you can do your own redirection, right? Let's say
We
you
need
are
to-
Right,
using.
it's not about capability. It's about API consistency, right? If I tell the telemetry
Oh, I
API
see
for
your
this
point.
namespace,
Yeah.
I want to go to Datadog. Now all the waypoints in that namespace go to Datadog, but none of the Z tunnels do. That seems surprising.
Costing.
Well, let's look at roles and who's managing each component. I mean, Z tunnel is kind of under the cluster admin purview, and they probably decide what they want at cluster level. Waypoints are normally under the namespace owner, and they may have different, composition, as Louis is saying. I mean, different namespaces may have different things, and in general, perhaps the telemetry collector or other things should take care about where to send stuff and how to split it and how to send to multiple destination. And again, with open telemetry, the collector is usually per node or per cluster, and that's where the split is going to happen. So I don't even think we should worry about it too much, because it's not really our business to send data to Datadog. It should be the job of OpenTelemetry collector or some other tool that Datadog deals with.
Yeah, I want to add one more source to Mitch's concern, right? It's like a user experience, consistency of user experience. But even if we, let's say, imagine we forward the Z tunnel access log to Datadog, the format and the content still are not consistent, right? Because this Z tunnel access log is, whatever the, for example, the, source, destination, IP, port, this layer 4 information may not be consistent with the current ESQ access log.
I understand the complexity there. I'm concerned that, Costin, I understand from a technological perspective, there are other tools that can do this, and it's important to consider what belongs in Istio and what doesn't belong in Istio. However, we have a telemetry API that is currently in beta. It's going to V1 within the next few months. It seems inconsistent to push that up to V1 and then to have it be completely irrelevant to layer 4 telemetry in ambient mode.
Well, that's unfortunate, but that's reality. I mean, we are competing with Open Telemetry Collector and other standards that have broad industry adoption. Any user will be hurt by having, kind of confusion where, some stuff is configured by cluster operator and it's standard and common across proxyless regular applications and all of things. And only Istio have its own dedicated API, and you have to either duplicate or behave differently. And, it's for sidecars, we have no choice. I mean, that's API and that's the choice we made for Istio V1 API, but with a gateway API, I think we can afford to make some different, and besides, telemetry V1 doesn't specify where you send it. It's just the provider name, and that's kind of a bit more flexible. But we should not repeat the mistake that we did in, yes.
I see what you're saying, and maybe that's worth considering. But for my part, I would rather not have telemetry API in ambient whatsoever than have it control only half of ambient telemetry.
Oh, I completely agree with that. I mean, I was hoping that we'll minimize API, but zero API, it's even better than because again, there is an organization in CNCF that is dedicated to telemetry and is not us.
So that sounds like it's probably a longer conversation than we're prepared to have today, but I do think we ought to have it soon.
Yeah, Mitch, I agree with less configuration. So if the community prefer no configuration at all, even for waypoint, that sounds great to me, because, for example, we can always enable metrics and logs for waypoint. For tracing, we can have a fixed sampling rate, like 1%. So yeah, John.
Yeah, I'd be cautious to say the community is asking for this. I've never heard a user say, I don't want to be able to configure my telemetry. I think it's very common for users to configure their telemetry.
But,
so it seems...
John,
yeah.
Did users say you don't want to configure telemetry? I must configure it to an Istio specific API that only applies to Istio waypoints, and and then for each application and each thing, I want its own separate API.
Well, there's no other API that exists. So no one has asked to go implement this API because there's not a thing that exists. So
well,
we need to be practical. Hotel is not even working on this, right?
What do you mean? They have OpenTelemetry Collector has a stable configuration. I think it's V1. It's a config map, not a a CRT, but it's an API too.
So John, just a quick question. Users definitely want to configure telemetry. The telemetry API allows for very fine-grained configuration as opposed to like admin-only configuration.
Yep.
Do we hear users want to do anything other than admin-only?
That I have less data on. I could very easily see that being the primary demand, and I would be very skeptical of adding fine-grained in zTunnel, for example.
So, like, as an interim solution, you could say, look, no telemetry API, but mesh config to satisfy the telemetry configuration requirements for users.
Yeah. Yeah, I think something like that would be reasonable. Saying that we just can't customize it all and you always have 1% tracing, though, I don't think that would fly.
Yeah. Like I could certainly see like a use case for a dedicated, like, increase the sampling rate of tracing in this context API, but not changing the schema of the reported dimensions. At least not in maybe rare situations, right, where there's some app that just produces way too much telemetry and the admin needs to kind of carve it out. But giving everybody the ability to configure every aspect of telemetry is probably best.
So Louis, I think that was in favor of not having telemetry API in ambient. Is that correct?
Yes, at least starting there. and looking at adding a small number of knobs in mesh config to start with.
Okay. We should take that input into consideration as we evaluate moving telemetry API to V1 around, what does it mean for us to move it to V1 and then not carry it forward into ambient? Not saying that it's a deal blocker, but I'd like to make sure that we're consistent as we're considering this.
So just to confirm, so we are in favor of not providing telemetry API for beta, right?
Yes, I think it is acceptable not to provide the telemetry API for beta.
Great. Yeah, that sounds great. Yeah.
But there is the second, like, are there some configuration knobs we need to provide in mesh config, and what might those be? So that needs to be captured. And the answer could be none to start with, right? And that's fine. I think your document just needs to capture that. Right?
Yeah, I will update the doc about the consensus.
Thanks, Lee.
Thank you.
Well, I think that was the agenda, wasn't it?
The only other thing I had on the agenda was bugging people to consider if they're ready to sign off on the Auth-Z policy status RFC. Mike and Justin made some comments. I tried to, well, I'll probably take another pass today, but I think it's basically approvable at this point. Justin?
Yeah, I definitely liked it overall. One thing, and I don't have a better suggestion, was there was things baked in referring to the Z tunnel as like one of the authorization layers. And do we want to do that, in this sort of more generic approach that we're taking? Like Z tunnel is a particular implementation.
But I've tried to find a consistent word salad to kind of say Z tunnel and the other thing at the same time. I'm happy to take another pass at it. Usually I just do it once. It's hard for people, right? Because kind of this secure networking layer, right, is the alternative phrasing, and then some people lose context. So, yeah, I think I just have to say everything twice everywhere.
Right. No, I thought there was, maybe I need to look at it again. I thought there was, the kind is labeled as Z tunnel.
Oh, that's the status. So the thing implementing, and that probably is a topic that belongs in conformance, right? If Z tunnel is the thing implementing the security network layer, like it's the controller, logically, then it should be the one providing the status, and therefore its kind should be actively reported in the status. If something else was doing it, then it should be reported. If there's a question about how to make tooling work with that from the status side, it's a good question. So let's take that one up in the doc. I generally lean, and I think the Gateway API spec does this too. When status is provided, we try to refer to the concrete implementation.
Okay.
Let people know what's causing this effect, rather than, I guess, what would be the standard, for want of a better term.
Okay. Yeah, then maybe even, and I'll add something, maybe we even just say a sentence in there that just says that, just so people don't, and like you said, I think it's around conformance, just so people don't build things around that, expecting it.
Yeah, it'll be really interesting to see the second order derivative effect of the Gateway API and all its status standards and how that will affect tooling down the road. That is uncharted territory, I think, at scale. Kubernetes has certainly struggled with this for other things. So, yeah. Expect bumps, I guess is the answer.
Right, yeah. And that's why I almost feel bad. I don't have a better suggestion. I just wanted to call up that maybe we should think about it. But yes.
Yeah. No, it's a good point.
Thanks.
Okay, folks, please take a look. If you're ready to approve, you can do the usual kind of directional or X approval status thing. No doubt there will be some adjustments made. Testing. I think it's pretty solid overall at this point. All right, I guess I'm gonna stop the recording unless there's any last minute stuff.
Thanks, everybody.
All right,
See you next week.
Yep.
Thank you.